Hello and welcome to the Maths Matrix and part 2 of highest common factor and lowest common multiple. If you haven't watched part 1 yet, then I suggest you go and have a quick look at that. In this video, we'll be discussing extensions and exam applications of highest common factor and lowest common multiple. Now, sometimes you are asked to find the highest common factor or the lowest common multiple of 3 numbers. So in part 1, we did a pair of numbers, and sometimes you might need to do it for 3 numbers. If you need to do it for 3 numbers, it works in the exact same way as 2 numbers, except that you have 3 factor trees to do and you have a 3-way Venn diagram to draw. So it gets a little bit more complex in the Venn diagram stage, but otherwise it's broadly the same. So let's have a look at an example where you're asked to find the HCF or the LCM of 3 numbers. So if you put, e.g., find the HCF and LCM of 36, 48 and 80. So I'll do my factor trees. I'm going to have to do them quite small or else I won't be able to fit my 3-way Venn in. 36 breaks down to 4 9s, 4 breaks down to 2 2s, both of which are prime, and 9 to 3 3s, both of which are prime. So you should have 2 2 3 3 in the Venn diagram at the end. 48 breaks down into 4 12s, 4 breaks down into 2 2s, 12 breaks down into 3 4s, and the 4 breaks down into 2 2s. So you should have 2 2 3 2 2 in your tree. And then 80 breaks down into 8 10s, 8 breaks down into 2 4s, 4 breaks down into 2 2s, and 10 breaks down into 2 5s. So I've done that quite quickly, but it's just the same as before, except I've now got 3 trees. I'm then going to do a 3-way Venn diagram, and I'm not sure how clearly you'll be able to see this, so I'm going to talk through what's going where as I'm doing it. So I want 3 interlocking circles. And one of the circles is going to represent 36, one's going to represent 48, and one's going to represent 80. Then this is where it gets a bit tricky just because there's a lot to look at. 36, 48 and 80 all have 2 in their factor trees. So in the very middle of the Venn, I'm going to put 2, the bit where all 3 circles overlap. And I'm going to cross 2 off all the ends. They all have another 2, so I'm going to put another 2 in and I'm going to cross it off all the ends. They don't all have anything else in common, but 36 and 48 both have a 3. So between the 36 and 48, where they interlock, I'll put a 3 and I'll cross it off their bits. Then 36 has a spare 3 that nothing else shares, so I'll put that there. 48 and 80 both have another 2. So between 48 and 80, the bit that they share, I'll put a 2 and I'll cross that off each. 48 and 80 each have another 2, so I'll put that in their shared area and cross it off each. And then 80 has a 5 that's not shared with anything else, so I'll put that in just 80's part. So that's what my 3-way Venn ends up looking like. Then it works the same as before. The highest common factor is given by the bit that all 3 circles share. So it's given by this bit here, right in the middle, because that's the only bit that all 3 numbers share. So the highest common factor is 2 times 2, which is 4. The lowest common multiple is everything in the Venn diagram. So that's going to be 3 times 3 times 2 times 2 times another 2 and another 2 times that 5 there. So 1, 2, 3, 4, 5, 6, 7 numbers in the list. 1, 2, 3, 4, 5, 6, 7 numbers in the Venn, so I can check that I've got them all. 3 3s are 9, times 2 is 18, times another 2 is 36, times another 2 is 72, times another 2 is 144. 144 times by 5, don't know what that is off the top of my head. 5 4s are 20, 5 4s are 20, 21, 22. 5 1s are 5, 6, 7. So the lowest common multiple of all the three numbers is 720. So once you've got your Venn, it does work the same. It's just that the drawing of the Venn is harder because you have 3 different bits to keep track of and quite a lot of separate areas that you could put things in. So if you have a go at find the HCF and LCM of 90, 120 and 180. So have a go at that, hit pause when you've tried it, hit play, and I'll go through it. All right, so 90 breaks down into 9 times 10, which breaks down into 3 and 3 and 2 and 5. So you should have 3, 3, 2, 5 in your tree. 120 breaks down into 12 times 10, which breaks down into 3 times 4, which breaks down into 2 2s, and your 10 breaks down into a 2 and a 5. So you should have 3, 2, 2, 2, 5 at the end of your tree. And 180 breaks down into 18 times 10, which breaks down into 3 times 6, which breaks down into 2 times 3, and your 10 breaks down into a 2 and a 5. So you should have 3, 2, 3, 2, 5 in any particular order in the end of your 180 tree. Then we're going to put it into a Venn. So I'll draw my 3-way Venn diagram there. And they all have a 3, so I can put 3 right in the middle and cross it off them all. They all have a 2, so I can put a 2 in the middle and cross it off them all. They all have a 5, so I can put a 5 in the middle and cross it off them all. I've forgotten to label my Venn. This is 90, that's 120, and that's 180 there. Then 90 and 180 both share another 3. So between 90 and 180 in that shared area, I'll put a 3 and cross it off. Then I have a 2 that's shared between 120 and 180. So I'll put that there and cross it off both. And then in the 120 column, I have an extra 2 and an extra 5 that isn't shared with anything. Then my highest common factor is 3 times 2 times 5, which is 6 times 5, which is 30. And my lowest common multiple is 3 times 3 times 2 times 5 times 2 times 5 times 2. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Doesn't matter if you've got them in a different order to me. 3 3s are 9. Times 2 is 18. Times 5 is 90. Times 2 is 180. 180 times 5, I don't know. So 5 zeros are 0. 5 8s are 40. 5 1s are 4, and add the 4 on makes 9. So that's taken me up to 900, which needs to be times by 2 to give me 1800. All right, so your HCF and LCM for that one should be 30 and 1800. If you do another three-way example, so if you do find the HCF and LCM of 75, 100 and 140. So I'll have a go at that and then I'll go through it with you. All right, so 75 breaks down into 3 times 25 and the 25 breaks down into 5 5s. So 355 is what you should have in that tree. 100 breaks down into 10 tens, which breaks down into a 2 and a 5 and a 2 and a 5. And 140 breaks down into 14 times 10, which breaks down into 2 times 7 and 2 times 5. So you should have 2525 in one tree and 2725 in your other tree. Draw my three-way Venn diagram. So 75, 100 and 140. In the middle of the Venn, they all have a 5. So everything's got 1 5 that it can give. So I'll put 5 in the middle and cross everything off. They don't have anything else in common between all three. So all that goes in the middle in this case is a 5. 75 has a 3 that nothing else shares, so I'll put that there. 75 has a 5 that is shared with 100, so I'll put that in their shared area. 100 and 140 both share a 2, so I'll put that in their shared area. And they both share another 2, so I'll put another one in their shared area. And then 140 has a 7 in it that nothing else has. And then the highest common factor is just the middle of the Venn, which is just 5 in this case, nice and easy. And then the lowest common multiple is going to be everything times together. So 3 times 5 times 5 times 2 times 2 times 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I've got them all. Right. What I'm going to do is I'm going to cheat this one a little bit. That circle there all represents 100. So those 4 components times by together must make 100. So that circle represents 100. 100 times 3 is 300. So now that bit's gone as well. And 300 times 7 is 2,100. So all those bits together are 2,100. All right, so hopefully you got that one right. Now they can't really hide highest common factor questions on exams, or not that I've seen before. But what they do sometimes do is give you an exam question that's slightly backwards. So an example of that might be, the lowest common multiple of 40 and x is 200. The highest common factor of 40 and x is 10. What is x? So if you pop that down as an example, I'll go through that with you. So actually write the wording. So the LCM of 40 and x is 200. The HCF of 40 and x is 10. What is x? Now, if we think about what we do in a normal highest common factor, lowest common multiple scenario, we draw factor trees. So we'd have a factor tree for 40 and we'd have a factor tree for x. and then we would draw a Venn diagram. And in the Venn diagram for 40 and x, we would end up with the highest common factor. So the highest common factor of 40 and x is 10. So whatever went into the middle of the Venn diagram, it must have produced an answer when it was all times together of 10. We know that this circle of the Venn here times is together to give the number 40, because this circle represents 40's side. So whatever went on this side of the Venn, it must all have times together to give 4. So this circle here represents 40. We now have the final bit of information that the lowest common multiple is 200. So we know that when we multiply all of the Venn together, it had to produce an answer of 200. Well, this part of the Venn here represents 40. So the left-hand side of the Venn is 40. And we know that that 40 needs to be multiplied by something here to produce an answer of 200. So the something there must have been 5, because 40 times 5 makes 200. So the missing number on this side of the Venn diagram is 5. And then this whole circle here represents x. And so x must have been those two numbers times together, which is 50. So if they give you a backwards highest common factor, lowest common multiple question, just think about what you would do if it was forwards. You would draw your factor trees and put the information into a Venn. So set your Venn diagram up and put the bits you know into the right spaces, and that should enable you to get to the answer of whatever it is that they're asking. So that's an exam application in a backwards kind of way. Now, I can't really think of any other ways that they could hide a highest common factor question. In general, if they want you to do highest common factor, they just say so. They just say find the highest common factor of these numbers, usually for a nice easy 3 marks. They can hide lowest common multiple, and the way that they usually hide lowest common multiple is they might say something like highlighters are bought in boxes of 25 and marker pens are bought in boxes of 30, and at a conference everybody's going to need 1 highlighter and 1 marker pen, and there mustn't be any leftovers. What's the smallest number of people that need to attend the conference? That is lowest common multiple in disguise. It's asking you to find the lowest common multiple of 25 and 30. Another way that they can do it is they can say 2 runners start a race on the start line at a certain moment in time, and runner A does a lap every 90 seconds and runner B does a lap every 110 seconds. When will they next both cross the start line together? That's another lowest common multiple in disguise. Or they might say something like buses leave a bus station every 15 minutes and trains leave the train station every 18 minutes. They both leave at 10 a.m. When are they next going to both leave at the same time? Again, that is a lowest common multiple in disguise question. So lowest common multiple can be hidden in a way that I've never seen highest common factor being hidden before. All right. So we'll just have a look at an exam application of that. So if you actually write this question, I'm not going to write the whole question out, otherwise I'll have run out of paper before I get to my working area. So actually write this question down. And if you put, at a Christmas party, party hats come in packets of 24, and party poppers come in boxes of 40. Each person is to get 1 hat and 1 party popper. There must be no leftovers. What is the minimum number of people at the party? So what we're basically being asked is, what is the lowest common multiple of 24 and 40? So if you actually want to put that in brackets, you can do. If you're not sure and you think you might need to revise this from notes at some point, actually put, this is asking what is the lowest common multiple of 24 and 40. So I'll break 24 down into 4 and 6. And 4 breaks down into 2 times 2, and 6 breaks down into 2 times 3. So now I have my factor tree for 24. 40 breaks down into 4 times 10, 4 breaks down into 2 2s, and 10 breaks down into 2 5s. So that's my factor tree for each of those. If you need to, just pause and copy it down. And then I'll draw a Venn diagram. They've each got a 2. They've each got another 2. They've each got another 2. 24 has a 3. 40 has a 5. In this case, we're not being asked anything about highest common factor, so we don't need to work that out. It's only asking about lowest common multiple. So 3 times 2 times 2 times 2 times 5. That whole bit represents 24. And 24 times 5 is 120. So the lowest common multiple is 120. And so in the context of the question we were given, the minimum number of people at the party is 120. What they'll then sometimes do is they'll put a little extension on saying how many packets of party hats and boxes of party poppers need to be purchased. After that, it's just a case of dividing. If the party hats come in 24s, then you do 120 divided by 24, and that tells you how many packets of party hats you need. If the party poppers come in boxes of 40, then you need to do 120 divided by 40, and that tells you how many boxes of party poppers. So in this case, it would be 5 lots of party hats and 3 lots of party poppers. Okay, so what I'm going to do now is I'm going to put back on screen the questions that I showed right at the beginning of highest common factor and lowest common multiple, and hopefully now you'll know how to do them. I am going to show some answers as well, so that you can check that you got them right. So if you hit pause on the first screen to have a go at the questions, then right at the end there'll be answers to those questions so that you'll be able to mark them. Thank you very much for watching, and I will see you next time. Bye!